Today we are talking about the meaning of a limit. Now, all at the top we have this mathematical definition of a limit, and lucky for us, we will not have to work with this definition. So you might see it someday. You can read it if you'd like. I'm going to move on. When we look at these graphs, we should be able to identify these limits graphically. So again, this should be a review. You've done limits in your past mathematical career. We're just refreshing our memories on this. So in number 1, we are trying to find what is the limit as x approaches c from the right. As x approaches c, excuse me, I think that's from the left. So from the left, I'm coming from the left side, I come over, and I come over, and that is what the limit is approaching as x approaches c from the left, and that value is 5. Then what I'm going to do is I'm going to find the limit as x approaches c from the right. So I come down from the right, and the y value I'm approaching is 5. So then the question is, well, what is the limit as x approaches c? And that limit is 5. From the left and from the right, we're approaching the same value. Moving on to number 2, when I look at the limit as x approaches c from the left, I'm coming here, and the y value here is 4. And when the limit as x approaches c from the right, that's going to be this one. I'm coming from the right, and I'm approaching 7. So this limit as x approaches c in this particular case does not exist. And I don't know what it's approaching. It's approaching 2 different values, so all I can say is it does not exist. Number 3, we have the limit as x approaches c from the left. And from the left, it does not exist. However, I know what it's approaching, so I need to say that. So I need to say, I can say the equal sign with the arrow after it, and it's approaching positive infinity. Coming from the other side, again, it does not exist. However, I know what it's approaching, and it is also approaching infinity. Therefore, with the actual limit as x approaches c, it does not exist, but I need to indicate that I do know where it's going, and it is approaching infinity. We're going to move on now to the next page. Now, looking at this, part 1, limits from a table, what I would like for you to do is I would like for you to complete the table. So go ahead and type x squared minus 9 all over x minus 3 into your graphing calculator, put that in y1, then use your table, but set your table so that you are on auto. So in your y equals, we're going to have this x squared minus 9 in our numerator divided by x minus 3. Once I have that in, what I'm going to do is I'm going to set my table. So to set my table, I need to go second and window. And basically, I don't care about any of this. What I really want to do is I want to set my independent variable to ask. That way I can enter any x value that I want, and the calculator will tell me what the y value is. When I now go to table, it's blank. The first x value I want to put in is 2.9, and then I'm going to write down the y value. Please be careful when you've got extra decimal places. You need to be sure and highlight the y value, and then be sure you're looking at the bottom of the screen for all the decimal places. So please pause the video now and complete the table. Here is my completed table. Sorry, my numbers didn't fit in those little tiny boxes. So at this point, what I would like for you to do is I would like for you to complete A through E for number 1, and I want you to pause the video to do that. So please press pause now and complete A through E. Okay, the answers for A through E are listed. A is does not exist. B is x is an element of the real such that x is not equal to 3. C, both blanks are 6. D, both blanks are 6. Part E, yes, the limit exists. The justification is from the left of x equals 3 and from the right of x equals 3, g of x is approaching 6. Symbolically, we write the limit as x approaches 3 from the left of g of x is equal to the limit as x approaches 3 from the right of g of x, which is equal to the limit as x approaches 3 of g of x, which is 6. Now, these are, again, estimates. We are using a table of values. We are going to get into the algebraic version of how to do this. However, for the practice that's listed below, we're going to need to make a table of values. And what I'd like to do is go ahead and make your X values that you're going to use for each of these. Both of these are finding limits around X is equal to 0. So basically what we want is we want to make a table of values. And the middle of our table of values should be 0. That's what I'm trying to get close to. Really, really close to that is going to be negative 0.00001. Further away from that, okay, so I'm just making values very close to 0. I don't care really about 0.1. I care about things closer and closer to 0. So these are on the left. They're the negative values. Then we're going to do the same thing with the values on the right. Again, what you're going to do is you're going to use your table. You're going to leave it in the mode that it was in because it's in the mode so that it will ask you for what X values you want. You're going to go ahead and key those in, and then you're going to complete your table. I need you to please do that for number 1 and number 2. So please pause the video and do those 2 problems. Here are the completed tables. And when you're giving numerical evidence, the 4 decimal places isn't necessarily a good place to stop. It depends on how many decimal places there are that are relevant. I probably did a little bit of an overkill here. We probably don't need all of these decimal places because I think that what we can do is figure out what do we think that these limits are approaching now that we have our table. So to answer the question in number 1, it looks like our limit is approaching 1. And in the second one, it looks like our limit is approaching 0.167. And we can say that with, I'm fairly confident in those 2 values. I would have also taken in the second one or 0.17. Moving on to the next page. In this one, we are looking at this graph and we're trying to identify these limits by using the graph. So again, what I'd like for you to do is actually complete these on your own. And then what I'd like for you to do is check your answers with mine. So right now, go ahead and pause the video. So here are my answers. Number 1 is 2. Number 2 is 0. Number 3 is 2. Number 4 does not exist. Number 5 is 2. Number 6 is 1. Number 7 is negative 1. Number 8 is 1. Number 9 is negative 1. Number 10 is negative 1. Number 11 is negative 1. Number 12 is 0. Number 13 does not exist. Number 14 is 1. Number 15 is 2. Number 16 is negative 2. Anything is red means we are approaching from the left. Anything in blue means we were approaching from the right. Anything in black means it's the actual limit or the actual function value. So let's move on to the next one. In this one, we are sketching a graph of a function that satisfies every single one of these following conditions. So we have to meet all of these. So I'm just going to start by reading through and seeing what I can plot on my graph. So my domain goes from open interval of -6, which means that x is -6, there's going to be an open circle, not a solid dot. It is including +6. So when x is +6, I will have a solid dot on my graph. The second bullet says f of x is undefined at x is -6. So we'll have an open circle at x is -6. We also will have an open circle at x is 4 because f of x is undefined there as well. I can't plot anything yet. Third bullet, f of -5 is 0. Great, so I can actually plot that point. So f of -5 is 0. So I can put a point right on my graph, solid dot. F of -2 is +1. Again, I have a point that I can place it on my graph. F of 6 is +2. Again, I have a point that I can place on my graph. So those points are there. The next bullet, we have the limit as x approaches -6 from the right. So that's coming from here towards -6. My limit value is at 1. That actually tells me quite a bit. That tells me that As x approaches -6, my limit's trying to be 1. I know I can put an open circle right there. I know that because my domain does not include -6, so it has to be an open circle. The second bullet told me f of x was undefined at x is -6, so again, it has to be an open circle. But the limit from the right is trying to become a +1. So I know it has to go through, towards, excuse me, the open circle at -6, 1. The next limit we have is as x approaches -2 from the negative side. So in this case, we are coming towards -2 this way. That limit is approaching -1. Now, looking at my graph, I already have a solid dot when x is -2, which means I know that from the left, I'm going to have an open circle when x is -2 and y is -1. And right now, I'm going to guess that I could sketch a curve between these two open circles, making sure I go through the solid circle. But I'm going to go ahead and read everything else before I fill that in. The limit as x approaches -2 from the positive side, however, is 3. Now, again, at x is -2, I have a solid dot, which means at +3, I have to have an open circle. And the last bullet, I have the limit as x approaches 2 from the left is -3. So again, I need to have an open circle. I'm not really sure what's going on here. And I don't know if I'm defined or not at x is equal to 2. So I'm going to put an open circle where x is 2 and y is -3. The limit as x approaches 2 from the positive side, however, is +2. So again, I'm going to put an open circle right there. I don't know if it's closed or open. Finally, I have the limit as x approaches 6 from the left, and that limit is at +1. Again, I have a solid dot for when x is equal to 6, so I have an open circle right there. At this point, I need to pay attention, but I should be able to not connect my dots exactly, but I should be able to sketch my graph. So I should have a limit coming through here. So the limit as x approaches -6 from the left is +1. Excuse me, from the right. The limit as x approaches -2 from the left is -1. Then I have these values. I don't really know what goes in between when x is -2 and when x is +2, but I know the curve should go through there. And I also don't know exactly what happens between x is 2 and x is 6, but the curve should go in there. I would not take off any points if there was a solid dot somewhere where x is 2. However, you cannot have the solid dot at both places where x is 2. Below that, part 3, those are all the limit laws. That's everything that you should already know. You might want to pause the video and take a look at those, but I don't know that any of those are surprises. Going on to the next page. I'm going to go ahead and say we are going to skip 1 through 4 at the top. We're going to do those in class. So we are going to jump down to part IV and solving limits analytically. And what I'd like for you to do is do A through G. And when you have those finished, go ahead and play the video again. And you can check your answers and then move on to the practice. So right now, pause the video so you can do A through D. Okay, so answers A, I got -2, B, I got 12, C, pi, D, 5, E, -1/4, F does not exist, G, -1/2. So at this point, if you need to correct something, please hit pause so you can try and figure out what's wrong with yours and what I did in my solution. Once your answers are all great, I would like for you to move on, please, to the practice 1 through 5. And again, pause the video, do the problems, and then hit play again to see the answers. So please hit pause. Here are the solutions to the practice 1 through 5. Number 1 is 15. Number 2 is 0. Number 3 is 6. Number 4 is -1. Number 5 is 6. So at this point, if your answers are not correct, you need to pause the video so that you can fix any of your errors. If you are finally correct with all of this, we're going to stop here. You're going to complete the remainder of the packet in class, and you are finished with today's video lesson. Please bring any questions that you have to class. Have a great day.